Hi guys, welcome to the today's session of divide and design and analysis of algorithms. In today's session, we are going to discuss about one more application of divide and conquer algorithm design strategy, which is nothing but merge sort. What is merge sort problem statement? Given an array of n elements, the merge sort problem can be defined as sorting the elements present in the given array into either increasing order or in decreasing order. How divide and conquer strategy sorts the given array? If that array contains number of elements, n number of elements. In divide and conquer strategy, the sorting can be done by splitting the array into two halves, recursively sort each half and then merge the two sorted subarrays. That is merge sort follows divide and conquer strategy. It is going to divide the array into two halves. These two halves are recursively sorted. After sorting, these two sorted subarrays are merged together. Right. In merge sort, we divide the array till it can be sorted without further splitting. That is, we are going to divide the array till we get a single element in each subarray. If the subarray contains a single element means it is already sorted. That is, if my array contains 10 elements, we are going to divide the array into 10 subarrays. Each subarray contains one single element. First subarray 1 contains one single element that is already sorted. Second subarray, that also contains only one single element that is already sorted. So, I'll get 10 sorted subarrays. These 10 sorted subarrays are to be merged one by one, merged together to get the sorted array. So, I hope that you understand the problem statement. So here I am going to play a small video which explains the sorting of subproblems. Thank you for listening. So I hope that you all understood the merge procedure, how she done. So first she divided the elements. So totally she contains 8 elements. Those 8 elements are divided into 8 subarrays. She all those 8 subarrays are sorted individually since they contains a single element. Now she merged two subarrays, two elements she merged, then four elements she merged. Like that she got a sorted array, right? So here you can clearly understood one more thing. So here this is one subarray and this is another subarray, right? Now first it goes to sort this subarray. So when this subarray is sorted, we will get the elements are like this. So when this subarray is sorted, we will get the elements as like this: 2, 9, 11, 13, 57. When this subarray is sorted, I'll get the elements as 1, 3, 17, 25, and 90. Right. Now, how to merge these two subarrays? The first element in the first subarray is compared with the first element in the second subarray. Out of these two, if I want to arrange them in the increasing order, since I arranged all the elements in increasing order in both the subarrays, I want to do the ascending order arrangement. So that's why, which is less element, that element is represented here, right? So since I completed the merging of this element, so I'll consider the next element from this list only. Now this element is compared with this element. Now since this is less one, this element is moved here and this element comparison is done and it is moved, it is sorted. Now I'll take the next element from here. I'll compare this element with this element. Now since this element is less, this is moved here and the next element from the same list is selected. Now this element and this element are compared. Now this is less. Now here this is represented. And I'll consider the next element from this list, that is from which the element is moved. From the same list I am considering the next element. Now 11 and 17 are compared. Since 11 is smaller, here 11 is represented. And from the same list, I am going to take the next element, 13. 13 and 17. Again, 13 is smaller. So 13 is moved here. Now, and I am taking the next element, 57. 57 and 17 are compared. Here 17 is smaller. So 17 is moved here. And the next element from this list is selected, which is compared with this element. Here 25 is less. So 25 is moved here. Next element from the list is 90. Now 90 and 57 are compared. The 57 is smaller here. So 57 is moved here. 57 is moved here. And finally, what the elements present in this list. Since all the elements in this list are completed, we have to move the elements which are remaining present in this list. So finally, we will get a sorted array. So this is the procedure of merging. This is the procedure of merging involved in merge sort. Now here you can clearly understood one more example. Here you are given an array which contains 8 elements. So this contains 4 elements. We are dividing the array into 2 subarrays. This contains 4 elements and this contains 4 elements. Now here you have an array. Here again this subarray is divided into 2 halves. This contains 2 elements and this contains 2 elements. Again, this also divided into 2 parts. This contains 2 elements and this contains 2 elements. Again, this subarray is divided into 2 parts. First one contains a single element, second one also contains a single element. Now this is also divided into two parts, this one and this one. This is also divided into two parts, this one and this one. This is also divided into two parts, this one and this one, right? Now the array, the given array which contains 8 elements is divided into 8 subarrays. Is divided into 8 subarrays. Now these two subarrays are merged. Now this is sorted subarray and this is another sorted subarray. These two are merged together. I'll get this sorted array. Now which is the solution for this one, right? Now here again these two are merged, which gives the solution for this one. Now these two are merged, which gives the solution for this one. Now these two are merged, which gives the solution for this one, right? Now these two are merged together. Now how these are merged? First the smallest element, first this element is compared with this element, 14 and 15. Since 14 is less, 14 comes here. After that 32 and 15 is less, so 15 comes here. Next 27 and 32, 27 is less, 27 comes here. Then finally all the elements are completed here. The remaining elements from here can be written. Here I'll get a sorted array, which is the solution of this one, right? Here also these two are merged, right? First 7, then 23, then 26, and finally 31, which gives the solution for this subarray. Now these two are merged. Now 14 is compared with 7. 7 is less, so 7 comes here. Next 23 and 14 are compared. 14 less, so 14 comes here. Next 15 and 23. 15 is less. Now 27 and 23. 23 is less. Next 27 and 26. 26 is less. Next 31 and 27. 27 is less. So next 32 and 31. 31 is less. So 32. So this is the solution for given array which contains 8 elements. So I hope that you all understood the procedure of merging. So here this gives the merge sort algorithm which follows divide and conquer strategy. Here A low to high is the array which I want to sort. If low is equal to high, that is only one element is there in the array is already sorted. And else if low less than high, that is more than one element, in that case we will find the mid value and we will call same algorithm for low to mid, and we will call same algorithm for mid plus 1 to high. That is, we are dividing the array at mid. One is left subarray, low to mid is left subarray, mid plus 1 to high is right subarray. Once these two are sorted, we'll call merge procedure from low, mid to high. Right? So like that, we are dividing. Now here, this entirely explains the merge procedure, what I explained earlier. Right? So from the left subarray and right subarray, I need to take first element from the left subarray, first element from the right subarray. These two are compared. Which is less element, that element is moved. And from where the element is moved, we will take the next element. Again, these two are compared. Like that, we will follow the merging procedure. Right? Now here, the time complexity for merge sort problem can be represented by using this recurrence relation. Now T of n is equal to A when n is equal to 1, and T of n is equal to 2 into T of n by 2 plus Cn when n is greater than 1. That is, when n is equal to 1 means only one element is there. I'll take a constant time. So that's why it is represented with A. And when n is greater than 1, and that is more number of elements are there. In that case, it takes much time. That is, dividing is there and conquering is there. So that's why it takes much time. That can be represented with the time complexity of sub-problems. So 2 into T of n by 2 plus Cn. Now here, by solving this recurrence relation, either by following the substitution method or by following the Master's theorem, we will get the time complexity as big of n log n. Big of n log n. So I hope that you all understood the merge sort problem and its procedure to solve. Thank you for listening.